Hello everyone, a very good morning to all of you. So we are now discussing the chapter that is atoms, and in atoms till now we have discussed about various structure of atom. Then first thing that we have discussed is our last class is about Thomson model. The Thomson model, so what is the output, what is the major advantage of Thomson model? That atom is neutral. तो थॉमसन का ये सक्सेस था कि एटॉम न्यूट्रल होता है. न्यूट्रल मतलब नंबर ऑफ पॉजिटिव चार्ज और अमाउंट ऑफ पॉजिटिव चार्ज इज इक्वल टू अमाउंट ऑफ नेगेटिव चार्ज. ये था थॉमसन. देन फ्रॉम थॉमसन द नेक्स्ट एक्सपेरिमेंट वाज डन बाय रदरफोर्ड. तो फ्रॉम रदरफोर्ड वी गॉट द आइडिया अबाउट न्यूक्लियस दैट इनसाइड द एटॉम at the center of it entire positive charge and the mass is supposed to be concentrated. This is known as your nucleus. Okay, and from Rutherford there are various drawbacks. Drawbacks क्या था कि when the electron will revolve around the nucleus, then due to the Coulomb's force of attraction the electron will move towards the nucleus, and finally the radius will keep on decreasing and decreasing. It will obey a spiral path and finally it will merge into the nucleus. मतलब electron will be destroyed, which is not possible. This is the major drawback of Rutherford model of an atom. Then it was even unable to explain the spectrum or that one. It was unable to explain the spectrums. Okay, that is the spectral lines. Okay, वो शब्द मेरा पास नहीं आ रहा था. spectral lines. तो what do you mean by spectral lines? Actually ये spectra क्या होता है? Spectra, what do you mean by the spectra or spectral lines? Okay, so you already know that the energy emitted by each photon or energy of each photon is given by E equal to h nu. Okay, so when electron will jump from higher energy to the lower energy orbits, वो तो Bohr's में आएगा. What do you mean by orbits? Then the electron radiates some amount of energy, and that amount of energy or electron releases some amount of energy, and that energy is nothing but energy of the photon. ठीक है, photon को energy कहाँ मिलता है? तो when electron jumps from higher energy to the lower energy level, then it will release some amount of energy. Okay, and that energy is nothing but energy of a photon. Okay, so Rutherford's model was unable to explain the various spectral lines, okay, of hydrogen atom or hydrogen like atom. तो Bohr's जो था, Niels Bohr, उसने आइडिया दिया था about this one, your spectral lines. Okay, so first thing that we will discuss is atomic spectra. So atomic spectra that we will discuss. Actually ये discuss करने का कोई बात नहीं है, इतना कोई है नहीं वहाँ पे. ठीक है, तो I will say something and you just make a note based on that. So atomic spectra, the atomic spectra is basically, it is of two types. Atomic spectra is basically of two types. When we will proceed in this chapter, then you will be able to know about spectral lines. So just you take some idea about spectra. So atomic spectra, it is basically of two types. One is line emission spectrum and another one is line absorption spectrum. So it is of two types. One is line emission spectrum and second one is line absorption spectrum. So in the first one it will emit some lights, okay, of different wavelength, and in the second one it will absorb. Line absorption spectrum. Okay, the first, what is line emission spectrum? It is a series of light of various wavelength emitted by atomic gas or vapor, usually exerted by passing current through it. Okay, the spectrum produced by the radiation by an excited element is known as characteristic spectrum. तो ये इतना अभी नहीं चाहिए, तो इसके बारे में अभी डिस्कस नहीं करते हैं. तो लेट अस स्टडी, ये इतना नहीं चाहिए. बस यू सिंपली राइट डाउन अबाउट that atomic spectra it is of two type, one is line emission spectrum and another one is line absorption spectrum. अभी हम लोग डिस्कस करने से तुम लोग थोड़ा कंफ्यूज हो जाओगे, तो इसीलिए अभी नहीं डिस्कस करेंगे, बाद में डिस्कस करेंगे आफ्टर डिस्कसिंग अबाउट बोर्स मॉडल ऑफ एन एटॉम. सो नाउ वी विल गो इनटू द बोर्स मॉडल ऑफ एन एटॉम. सो रदरफोर्ड का डिसएडवांटेज क्या था, डिसएडवांटेज ऑफ रदरफोर्ड, और ड्रॉबैक क्या था रदरफोर्ड का, ड्रॉबैक ऑफ रदरफोर्ड. सो ड्रॉबैक ऑफ रदरफोर्ड मॉडल, तो इसका मॉडल का ड्रॉबैक्स क्या था कि सपोज दिस इज द न्यूक्लियस हियर विच इज एट द सेंटर ऑफ द एटॉम, देन द इलेक्ट्रॉन, सपोज एक इलेक्ट्रॉन यहाँ पे है, so it will move like this, radius will keep on decreasing due to the force of attraction and finally the electron will merge into the nucleus, तो which is not possible. ये स्पेक्ट्रम अभी थोड़ा समय के लिए इसको रखो, इसको बाद में हम लोग डिस्कस करेंगे. तो अगर ये इलेक्ट्रॉन न्यूक्लियस में अगर मार्ज हो गया, इट मीन्स इलेक्ट्रॉन विल बी डिस्ट्रॉयड विच इज नॉट पॉसिबल. तो व्हाट इज द आइडिया गिवन बाय बोर, तो बोर साहब ने क्या बोला कि बोर्स मॉडल ऑफ एन एटॉम, यहाँ पे देखो बोर्स मॉडल ऑफ एन एटॉम. तो बोर said that in an atom there are some fixed energy level. Okay, suppose this is the nucleus. Bohr accepted the concept of nucleus and he said that surrounding the nucleus there will be some fixed orbit and it's in each orbit electrons will be there. Okay, इसको हम पूरा सेंटर पे ड्रॉ करता है. लेट मी ड्रॉ इट सेंटर, इतना बड़ा नहीं होगा, न्यूक्लियस बहुत टाइनी चीज होता है, बहुत ही स्मॉल. सो दिस इज द न्यूक्लियस एंड सराउंडिंग द न्यूक्लियस देयर आर सम ऑर्बिट्स, दे आर फिक्स्ड ऑर्बिट्स, और दिस ऑर्बिट it is number 1, this is number 2, this is number 3. These are also known as shell. This is K cell, this is L cell, M cell and like this. Okay, and electrons will be there in this cell. तो first orbit में कितना इलेक्ट्रॉन रहता है, 2 maximum. Second में कितना रहता है, 8. You know the rule ना, do you know the rule that when we will assign the electrons in various orbits, then the rule followed is this is known as Bohr's-Bury rule, which is known as twice n square. देखो, in the first orbit what is the value of n? N is equal to 1. So first orbit can accommodate maximum number of 2 electron. In the second orbit so for K cell, so for this is you already got in class 9. So for K cell what is the value of n? N is equal to 1. So maximum number of electron that we can accommodate is equal to 2 into 1 square is equal to 2. अच्छा, for K के बाद for K L cell, for L cell this is the cell number 2, so n will be equal to 2, so it will be 2 into 2 square is equal to 8. So the second orbit can accommodate maximum number of 8 electrons. So similarly the third orbit it can accommodate for K L M shell it can accommodate 2 into 3 square, that is 18. So this one can accommodate maximum number of 18 electrons. So this is known as Bohr's-Bury rule. Okay, so this is the Bohr's model of an atom. So according to Bohr's model of an atom, surrounding the nucleus there will be some fixed energy, or there will be some fixed orbits, and every orbit possesses different types amounts of energy. Okay, and they are known as shells. So we have to write the postulates of Bohr's theory, the very important question for your exam. So first we will write down postulates. Postulates मतलब जो rules होता है according to Bohr's model of an atom. तो ये थोड़ा लंबा होगा, but उपाय नहीं है, I have to write. An electron revolves around the nucleus. An electron revolves, this is very important. An electron revolves around the nucleus. An electron revolves around the nucleus with a definite energy, with a definite energy in a fixed path. with a definite energy in a fixed path known as stationary state, known as stationary state. Okay, this stationary state of the electron, this stationary state of the electron is called what? Is called energy level. Okay, what is the second one? So the second one is number 1. Number 2, an electron can revolve. An electron can revolve only in that orbit. मतलब कौन सा इलेक्ट्रॉन कौन सा ऑर्बिट पे घूमेगा, कौन सा ऑर्बिट पे वो रिवॉल्व करेगा. एन इलेक्ट्रॉन कैन रिवॉल्व ओनली इन दैट ऑर्बिट in which its angular momentum is equal to the integral multiple of of h divided by twice pi. So यहाँ से क्या समझ में आ रहा है तुम लोगों को? So what is angular momentum? Angular momentum is L equal to mvr is equal to what then? Integral multiple मतलब nh divided by twice pi. अब देखो, suppose this electron is revolving in the first orbit ना, तो what should be the angular momentum of this electron? It must be h divided by twice pi. Suppose another electron is there और उसका angular momentum कितना है? Suppose thrice h divided by twice pi. So an electron having angular momentum equal to thrice h divided by twice pi will revolve in the third orbit. Okay, that is why the second condition देखो, an electron can revolve only in that orbit in which its angular momentum is equal to the integral multiple of h divided by twice pi. Suppose एक इलेक्ट्रॉन है मेरा पास और उसका सपोज एंगुलर मोमेंटम है 5h डिवाइडेड बाय ट्वाइस pi. तो यहाँ पे n का वैल्यू कितना हुआ? 5 ना. सो दिस इलेक्ट्रॉन कैन रिवॉल्व ओनली इन द फिफ्थ ऑर्बिट. ओके, बात समझ में आ रहा है ना? सो देयर इज सपोज वन इलेक्ट्रॉन, इसका एंगुलर मोमेंटम कितना है? इसका एंगुलर मोमेंटम है सपोज थ्राइस h डिवाइडेड बाय ट्वाइस pi. तो यहाँ पे n का वैल्यू कितना होगा? 3. इट मीन्स दिस इलेक्ट्रॉन हैविंग एंगुलर मोमेंटम थ्राइस h बाय ट्वाइस pi इज रिवॉल्विंग इन द थर्ड ऑर्बिट. ओके, तो फर्स्ट ऑर्बिट का जो इलेक्ट्रॉन होता है इसका एंगुलर मोमेंटम अलग होता है, सेकेंड ऑर्बिट का जो इलेक्ट्रॉन होता है उसका एंगुलर मोमेंटम अलग होता है. तो in every orbit electrons are revolving and the electrons in different orbits are possessing different amounts of angular momentum. तो इसको याद रखना, this is known as Bohr's quantization. This is known as Bohr's quantization. ओके, इसका एक नाम है और वो नाम क्या है? इसका नाम होता है Bohr's quantization. ओके, याद रखना. So this is the second postulate of Bohr's theory. Done. So let us go to the third one. Third one already I have told you guys. Then when an electron jumps from higher energy orbit, that is देखो, in this direction energy always increases. So when an electron will jump from, say an electron is jumping from the third energy level towards the first one, it is jumping from the third orbit to the first orbit. तो यहाँ पे उसका एनर्जी ज़्यादा होगा, तो it will radiate some amount of energy and then it has to possess the energy equal to this electron. Then only it will be able to stay in the first orbit. So what is this energy? This energy will be given by h nu, and h nu is given by energy in the third orbit minus energy in the first orbit. देखो so this one will be the third postulate. तो third postulate पे हम लोग क्या लिखेंगे? इलेक्ट्रॉन कैन, थर्ड पोस्टुलेट पे हम लोग क्या लिखेंगे? इलेक्ट्रॉन कैन जंप फ्रॉम हायर एनर्जी लेवल टू द लोअर एनर्जी लेवल by radiating energy in the form of photons. Okay, so when an electron will jump from final energy to the it will jump from initial state to the final state, na? So when the electron will jump from initial state to the final state, this is nothing but delta E, and delta E is given by energy of the photon. So remember, this is the third postulate. So the postulates of Bohr's theory are very, very important. So first क्या मिला? The electron revolves around the nucleus in some fixed orbits, and they are known as your energy level. Each orbit has some different energy. इसका energy कम होता है, इसका थोड़ा ज़्यादा होता है, इसका और ज़्यादा होगा. तो in this direction the energy will keep on increasing. Okay, now we have to accommodate electron. Okay, तो the accommodation का rule क्या होता है? Twice n square rule. Now the thing is कौन सा electron कौन सा orbit पे आएगा, ठीक है? So this is the Bohr's quantization, that an electron can revolve only in that orbit in which angular momentum is an integral multiple of h by twice pi. You know what is h? Planck's constant, na? So the electrons that are revolving in the first orbit having an angular momentum of h by twice pi. In the second orbit they will be having an angular momentum of twice h by 2 pi. In the third orbit they will be having an angular momentum of thrice h by twice pi. Okay, so the third property is the electrons can jump. मैंने already बोला था polarization पे. देखो polarization पे मैंने क्या बोला था? I told you guys that the source of light is basically nothing but your atoms. तो in atoms पे क्या होता है? Atoms पे जो nucleus होता है उस पे तो कोई काम नहीं हो रहा है. तो electrons they are vibrating in various directions, ना? They are vibrating in various directions. So when electrons are jumping from higher energy level to the lower energy level, they will radiate energy in the form of what? Light. Okay, so these electrons, suppose an electron is jumping from third to first, तो यहाँ पे एनर्जी ज़्यादा, यहाँ पे एनर्जी कम. तो मान लो मैं था थर्ड पोजीशन पे, मेरा पास एनर्जी था 100 जूल, और फर्स्ट जो ऑर्बिट होता है उस पे एनर्जी कितना होता है? सपोज 20 जूल. तो आई हैव टू रिलीज एन 80 जूल अमाउंट ऑफ एनर्जी, एंड दैट 80 जूल अमाउंट ऑफ एनर्जी विल बी रेडिएटेड एज लाइट. Okay, and what is the energy of each light? Not each light, what is the energy of the photon? Photon means what? Photon they basically produce the light. So energy of each photon is h nu. So when it will jump from initial state to the final state, it will release energy, and that energy will be released in the form of what? Photon means light. So what we can conclude, that when electron jump from higher energy level to the lower energy level, it will emit light. You consider this case, यहाँ पे एनर्जी जितना रिलीज हो रहा है, when the electron will jump from 2 to 1, वहाँ पे एनर्जी रिलीज थोड़ा कम होगा. यहाँ पे एनर्जी रिलीज कम होने से फ्रीक्वेंसी अलग होगा. फ्रीक्वेंसी अलग होने से क्या अलग होगा? लैम्डा अलग होगा. लैम्डा अलग होने से उस लाइट का कलर डिफरेंट होगा. So when an electron is jumping from 3 to 1, then it will emit some light, and उसका कलर जो होगा, when the electron will jump from 3 to 2 or from 2 to 1, उसका अलग होगा. It will depend on energy. Okay, what amount of energy it is releasing. I think सबको बात धीरे धीरे समझ में आ रहा है, ठीक है? So now we have to calculate about the, ये जो ऑर्बिट होता है, ये ऑर्बिट का रेडियस, ये रेडियस कितना होता है? डिफरेंट ऑर्बिट्स का रेडियस कितना होता है? दैट इज वी हैव टू डिराइव नाउ. सो बोर्स मॉडल ऑफ एन एटॉम पे अभी हम लोग डिस्कस करेंगे. फर्स्ट वी विल गो फॉर रेडियस ऑफ द ऑर्बिट. एक मिनट रुको. So, from the Bohr's model to be continued. So, let us first discuss about radius of the orbit. Radius of the orbit. Okay. So, suppose there is suppose a यहाँ पे हम लोग लेते हैं suppose this one is a nucleus and what is the charge of the nucleus? Suppose E. मतलब यहाँ पे मान लो एक proton है. An electron is suppose revolving in any orbit. And what is the radius of this orbit? Suppose Rn. This is suppose nth orbit और यहाँ पे एक electron is revolving in this suppose direction. Then what is this radius? देखो the electron is revolving in a circular path, no? So force experience, पहले देखो हम लोग कैसे कैलकुलेट करेंगे कि force experienced by the electron. So what will be the force experienced by the electron? The force experienced by the electron will be Fe is equal to, instead of 1 by 4 pi epsilon naught, I will write here K. So K, charges are E into E. So K E square, E into E divided by distance is Rn square. Okay. अगर atom का atomic number Z है, तो what we will write there? Ze. So you can take the charge of the nucleus is equal to Ze. Z means number of proton, that is the atomic number of the atom, that is we are considering. So here we can write here Z into E. So the electric force or the electrostatic force is given by Ze square divided by Rn square. Now look at the diagram. The electron is revolving in a circular path. So a centripetal force will be required. So who will provide the centripetal force? So centripetal force will be provided by the electrostatic force. Okay? और तो कोई वहाँ पे दूसरा force है नहीं. तो centripetal force will be provided by the electrostatic force. So what is the centripetal force here? And velocity in the nth orbit. Electron is revolving in the nth orbit. तो यहाँ पे मान लो इसका speed क्या है? It is given by the tangent. Okay? So this is v. Vn मतलब velocity in the nth orbit. So it will be mvn square divided by Rn. I think you guys remember the formula of centripetal force, which is mv square by r is equal to kz E square. It will be kz E square divided by Rn square. So एक Rn यहाँ पे और ये cancel. So what is the formula that we got? That is m into Vn square is equal to k z E square divided by radius of the nth orbit. Done. So we got from Bohr's quantization, तो थोड़ा देर पहले हम लोगों ने डिस्कस किया ना Bohr's quantization. So from Bohr's quantization हम लोगों को क्या मिला था कि एंगुलर मोमेंटम ऑफ द nth ऑर्बिट इज इक्वल टू मास वेलोसिटी इन द nth ऑर्बिट Rn is equal to what? Is equal to nh divided by twice pi. From here, what is the formula of Pn? So Pn, from here it will be nh divided by twice pi m into Rn. So this is you can consider as a formula agar radius is given. So now you put the formula in this equation. ये इक्वेशन नंबर को तुम लोग 1 दे दो. सो इक्वेशन 1 implies m into Vn square. So m into Vn square मतलब n square h square 4 pi square m square Rn square is equal to k z e square divided by Rn. Okay, so Rn and Rn, it will cancel out. So what is the value of this Rn? So this radius of the nth orbit will be, oh, one m and m will get cancelled out. Is there anything to cancel? I think no. So अगर Rn इस डायरेक्शन में चला गया तो Rn will be n square into h square, this is h, Planck's constant, divided by 4 pi square m k z e square. This is the formula of radius of nth orbit. Okay, what is the radius of the nth orbit? The radius of the nth orbit will be, from here it will be n square h square 4 pi square m k into z e square for hydrogen. अच्छा, यहाँ से एक चीज क्या मालूम चल गया कि radius of the nth orbit is directly proportional to n square. Okay, from here you can write that radius of the first orbit divided by the radius of the second orbit is in the ratio of 1 square divided by 2 square, that is 1:4. Okay, so you remember these things. Acha, from there we can also write, what we can write, that for hydrogen, what is the value of Z? For hydrogen, the value of Z is 1. If you put the value of Z is equal to 1, then Rn will be equal to how much? Rn will be equal to n square comma h square, r equal to n square comma h square, 4 pi square m k e square. This is the value of Rn for hydrogen, because for hydrogen Z is equal to 1. Okay, so this is the radius of the nth orbit from Bohr's model. Okay, तो radius of the orbit हम लोगों को कितना मिल गया? n square h square divided by, थोड़ा सा मिस्टेक यहाँ पे, स्क्वायर नहीं है, तो 4 pi square m k z into e square. Z is equal to 1 for hydrogen, so that is the value. Okay, this is also important for your exam. Not very important, but important. So we will discuss about velocity and energy in our next class. Done.